Ever wondered how AI can understand both text and images, like describing a phone or answering questions about a chart? Today, we're diving into a breakthrough model called BlueLM-2.5-3B, a compact powerhouse designed to do all that and run smoothly on your phone or smart device. Most big AI models are like supercomputers, super strong, but not exactly portable. BlueLM-2.5-3B changes the game. With just 2.9 billion parameters, a fraction of larger models, it's the first 3B scale multimodal AI that can switch between two modes, thinking mode and non-thinking mode. Think of it like a flexible brain. Thinking mode lets it tackle complex problems step by step, while non-thinking mode speeds things up for quick answers. And here's the kicker. You can control how much thinking it does, saving energy and resources. So how did they build this? The team used a mix of diverse data, from text to images, even screenshots of apps, and refined it with smart techniques. They resampled the data to focus on what matters most, like teaching the model to reason through problems. Then they combined different training methods, called hybrid reinforcement learning, to make the model both powerful and efficient. The results? BlueLM-2.5-3B crushes benchmarks. In thinking mode, it's nearly as good as a 4B model on text tasks, and only trails a 16B model by 5% on image and text challenges. In non-thinking mode, it outperforms other 3B models on most tasks. And here's the secret sauce. It learns faster with less data than its bigger rivals. That means it's not just smart, it's efficient. But here's the real game changer. BlueLM-2.5-3B isn't just a theoretical leap. It's built to run on edge devices like smartphones and robots. How? By optimizing parameter efficiency and inference speed. Traditional multimodal models struggle with this because they require massive computational resources. BlueLM-2.5-3B solves this by using a modular architecture that separates text and vision processing, allowing it to allocate resources dynamically. Let's break down the technical magic. The model uses cross-modal attention mechanisms to align text and visual features, ensuring it understands context. For example, when analyzing a chart, it doesn't just recognize shapes, it maps them to the corresponding labels and data points. This is achieved through a shared embedding space, where both modalities are projected into a common representation. But how does it handle the sheer volume of data? The training process leverages distributed computing across GPUs, with pipeline parallelism to split tasks like tokenization, attention computation, and output generation. This reduces bottlenecks and ensures scalability. Plus, the team implemented quantization techniques to compress the model's weights without sacrificing accuracy, critical for mobile deployment. And let's not forget stability and fault tolerance. Even with 2048 GPUs, the system stays calm. It's like having a traffic cop monitoring everything in real time. If a glitch pops up, it auto-recovers, no human needed. They even trained for 139 hours straight without a single failure, proving its robustness. So what does this mean for the future? BlueLM-2.5-3B isn't just a model, it's a blueprint for edge AI. Imagine a smartphone that can analyze medical scans on the spot, or a robot that understands natural language instructions without cloud reliance. This is the next frontier of AI, and BlueLM-2.5-3B is leading the charge. Thanks for watching. If you're curious about the technical details or want to explore how models like BlueLM-2.5-3B are shaping the future, hit that subscribe button. Stay tuned for more deep dives into the cutting edge of AI research. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.